Alright guys, today we're going to be talking about correlation, so go ahead and get your notes set up, title it Correlation. Make sure you put this down in your table of contents. This is going to be what I call 4.3b. We're building off of the conditional relative frequencies that we talked about last week. So on your notes, go ahead and copy down this chart. Students were given the opportunity to prepare for a college placement test in math by taking a review course. So over here on the left, we have two categories. We have they took the course or they did not take the course. And based off of that, we have information saying that they were placed in the highest level math, 200. This is the hardest. A middle level math, which is math 100. And then placed in the lower level math, 50. And then the total out of how many people took the course and how many people did not take the course. So what we're going to do in order to see if there's any correlation between whether or not they took the course or they didn't and what math class they were placed in, we have to calculate their conditional relative frequencies. So we're going to do that on that first one by dividing each number by 60. This is going to give us 67%. Over here, we're going to get 22%. And then over here, we're going to get 12%. Now, I'm rounding to the nearest percent. Ideally, this should add up to 100, but again, I'm rounding. Now, to determine the conditional relative frequency for whether or not they did not take the course, I need to divide by 40. That marginal frequency. This is going to give us 25%. This is going to give us 38%. Another 38%. Now, like I said, I'm rounding, so this should add up to right around 100, but because I'm rounding, it might be off by a little bit. And then if we divide this column by the total, we get 50%, 28%, and 22%. Okay? These are easy because they're divided by 100, so it's just the frequency is now written as a percent. So what we want to do is we want to see if there is what's called a correlation. All right? Correlation means that there's a link or a relationship or some sort of connection. So, but before we can do that, we need to go over the 4 rules that determine whether or not there is a correlation. So, first of all, conditional relative frequencies matter when our totals Conditional relative frequencies matter when our totals are not equal. Okay, and what I mean by that is 60 and 40, these are our 2 marginal frequencies, they are not equal. So if the conditional relative frequencies are close together, there is no association. Or correlation. All right, these 2 words mean virtually the same thing. There's no association and there's no correlation. So let's see if there's any up here that are very similar. We've got 25 and 67. We determine if they're similar by subtracting. So if we subtract this, we get 42. That's pretty far apart. So I would say that this doesn't count. This one is 16% apart, and this one is 26% apart. So the closest one is here. So on the other hand, if the conditional relative frequencies are very far apart, then there is a correlation. Or association. And our last one is this big idea that correlation does not imply or mean causation. Correlation does not imply or mean causation. Now, let's go over the vocabulary real quick. I'm going to scoot this up. Correlation or association means that there's a link, connection, or relationship between two things. Causation means that there is a direct cause and effect relationship. So if we look at our chart above, zoom in so we can see everything. Do you think that there's a correlation between taking the course and getting placed in a higher math class in college? I would say that there is evidence of association because they're noticeably different for those who took the course and for those who did not take the course. So if they took the course, most of them are placed in a higher math class. So it gets higher and then it gets slowly lower. Whereas if you did not take the course, see how these numbers are trending up as they go to the right? We go from 25% to 38, and 38 stays the same. So there is a correlation. However, do you think there's a causation? Do you think that because they took the course, they got placed in a higher math class? This is the trick. You might think that because there's a correlation, there's automatically a causation. This course caused them to get placed in a higher math class. But what's a possible explanation that would explain why, instead of just the course, meaning another factor could influence whether or not they got placed in the higher math class or the lower math class? Another possible explanation is that students who took the review class or course are actually just more interested in math and were already better prepared for math and therefore perform better on the math placement test. Okay? Because typically, if you're not interested in something or you're not very good at it, you don't want to take another course in it. Whereas if you like something and you want to do something and you're already good at it, you're going to take another course in it. So just because they took the course doesn't mean they got placed in a higher math class. This is a great example of where correlation is not causation. This course did not directly impact what math class they were taking.